CodeME provides high-fidelity simulation of aerospace vehicles, and we do this from conceptual ideas all the way through flight testing. That consists of batch simulations that just usually require a computer monitor to access, all the way through piloted simulations.
Flaps in gear, and we're at 200 knots.
We also have the ability to connect into the hardware components, whether it be flight control computers or actuators, all the way through plugging full vehicles in the test bays out in the hangar. In addition to simulating individual aircraft, you have the ability to fly remotely augmented vehicles, so a pilot sitting in one of our labs can fly an uninhabited vehicle, or conversely, a pilot on an airplane can be looking at a display that's driven with algorithms running here in our labs. We also have the ability to take our sim lab and connect it as a component of a live virtual constructive environment. Simulated aircraft are now part of a simulation that combines real and simulated aircraft in a larger airspace like we do with UAS and the nav. If you want to build a simulation, you have your basic aircraft dynamics model, big mass properties type stuff. So that's one model that you have to start assembling with other things. You have to assemble it with an aerodynamics model, you have to assemble it with a propulsion and engine model, a set of guidance laws, and a couple of other models, and you just have to assemble all these things together. Once you build a simulation, it's used quite a bit for training the pilots, practicing maneuvers.
We're getting a little dynamic here.
Okay. Try to be stable up here to give you a stable platform to work off of.
Because you have a nice high fidelity sim, you know how long each maneuver takes, you know how long it takes in between maneuvers, so it allows you to optimize the available flight time, which is very expensive. Be it a center stick or a side stick controller or a yoke type controller, that would be modeled and simulated to behave just like the stick in the actual airplane. You could actually have force feedback so that it mimics the actual forces that a pilot would feel in the airplane.
Pretty well.
Data that we typically collect looks like flight data, and that data is used to verify whether or not the control algorithms were implemented correctly. The flip side of that is if there's an anomaly in flight after the plane goes into operational status, we would use the simulation to research and investigate and understand what might have caused that anomalous behavior. And that's something you only get with a high fidelity sim. It's not like the simulations that you get, from X-Plane or something like that. One of the projects we're starting to work on is getting Mars airspace up and running and setting things up so we can fly multiple Mars flyers, so we can start exploring aircraft on Mars to see how well they fly.